Alright, well this is the other end of my camera. The lens is all foggy, so it's all scratched up for some reason. When they designed this camera, they made the camera stick out farther than the casing. So anytime it laid on the table and I tried to fumble trying to get it up, I always ran it across the lens. So I just wanted to show you. This is, if you can probably see, there's the magnet. So it's not perfectly lined up. And the spacing is almost to where in the middle, you see the bottom one's catching the magnet right there, and the top one's that far away. If it was a little bit closer, it would actually help the bottom one break away if the top one was pulling towards it. If they were all perfectly spaced, it would be hardly any resistance on this wheel. But that's something we'll work on later. But I just wanted to show you, I got the motor hooked up and got the voltage up to there. So got the little trigger here. If I put this in here so I don't push it down too far. Okay, that didn't work. All right. Well, yeah, we'll just. Okay, so it wants to go that way. Okay. And I think I could probably try to flip this camera around. Maybe not. Oh, it is what it is. Okay. So sorry about the lens. I know it's a real foggy picture. But you can hear pretty much when it gets around to every revolution because it's got a couple magnets that are loose, so they move every time they get close to the magnetron. So you count 1, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Between 2 and 3 revolutions, it comes up 10 milliamps. And I've done it this way all the way up over 10 volts. It seems like the faster I run it, the better it charges, because all of a sudden it's like most of the time it's every 2 revolutions if I run it fast enough, but then it starts rocking and rolling the table, so I can't run it that fast. And you see how it jumps up like every 2 revolutions. Okay. One, two, 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 one, two. Yeah, I could run this motor for a little while, but then it starts getting kind of warm. So it skips. Sometimes it's every revolution it comes up 10. So definitely the faster I go, the better it charges. And if you take in consideration that the magnetron is supposed to be like a business card's width away from the wheel, and it is kind of hard to see. Okay. Try to get a different angle here. But you can tell it's away from there pretty good. Plus the magnets themselves are inset quite a bit. So between the two, I'm figuring 3/8 to 1/4 of an inch probably. So it's nowhere near as close as it's supposed to be. And I put a spark plug in there and tried to fire it, and it wouldn't fire. It doesn't generate enough to fire it, but it generates enough to charge the capacitor. But I'm just wondering if it was as close as it's supposed to be and it actually fit the wheel and spark the spark plug, would it charge faster? I'm assuming probably. So I'll fire it up again. Let's see which way it goes. Okay, so turn the wheel this way. Yeah, it's rocking and rolling. Okay. Yeah, it's not that warm yet. See if we can get it up to 10 volts here real quick. Yeah, its foot pedal's starting to get warm. But I can still hang on to it. I figured that the higher the charge, the slower it would start charging, you know, like kind of like building pressure in it or something. I guess it's not like that. I know it doesn't take hardly any current at all to charge a capacitor, and there's really no current coming from this except for the magnetic pulse from the magnet hitting the iron core. Probably averages out about every, yeah, it's getting pretty warm. I'm gonna go ahead and unplug it. Hey, say hi to our new chickens. Kind of foggy in there too. What are you doing, man? Okay, well, we'll just leave it at that. All right, thanks for watching.